Okay, suppose $3,000 is invested at 4% interest. Find the amount after 5 years if the money is compounded A, annually, B, monthly, C, daily, and D, continuously. First, if it's compounded annually, the formula is that the amount is equal to P times 1 plus R over N to the NT. And in our case, this would be 3,000 times 1 plus 0.04 over 1 to the 4 times 1 power. So if we just simply plunge that in, 3,000 times 1.04 to the 5th power, not the 4th power, that works out to be $3,649.96. And let me correct that. This should have been to the 5th power, not to the 4th power. So that's the first problem. The second problem, same idea. The amount would be equal to, well, this time it would be 3,000 times 1 plus 0.04 divided by 12 raised to the 5 times 12, or the 60th power. So let's see what happens this time. We get 3,000 times 1 plus 0.04 to the 12th, or divided by 12, whole thing raised to the 60th power, and we get an answer that is slightly larger, $3,662. And it should be approximately equal to, of course, $3,662.99. So the interest being divided into equal portions but compounded more frequently causes a net that is somewhat larger than it was before. Part C, if the interest is compounded daily, we would expect an answer that's still larger, slightly larger, but larger. So we'd have 3,000 times 1 plus 0.04 divided by 365, forgetting leap year, raised to the 5 times 365. So 3,000 times 1 plus 0.04 divided by 365 raised to the 5 times 365. And this works out to be $3,664.17. And finally, the limit. If it's continuous compound interest, the formula would then be P times e to the RT, which would be 3,000 times e to the 0.04 times 5. So that would be 3,000 times e to the 0.2 power, which is still larger, but not much larger, of course, $3,664.21. And so the frequency of compounding does affect the final result that you get. The more frequent the compounding, the slightly higher the amount will be at the end.